Hello, this is Mr. Stansbury. I'm going to take you through the notes on sets. Okay, at the end of this, you should be able to say I can use set notation to write and decipher information about sets and subsets. All right, so first things first, a set is a collection of numbers or objects. Okay, each object in the set is called an element or a member of the set. Okay, and a set is written with brackets as the notation. So for example, 0, 3, 11, and a fluffy unicorn, that is a set. Okay, and 0, 3, 11, and a fluffy unicorn are all elements or members of the set. Okay. A finite set is a set with a countable number of elements. Like this is a finite set. There's 4 things in there. And an infinite set is a set with an infinite number of elements. Okay, so that would not be countable. All right. Set notation. This funny looking E stands for is an element of or is in. So for example, if set A is 4, -2, and 7, 7 is an element of set A, is how that would be read. Okay. Next thing we have here is the funny looking E with a slash through it is not an element of or is not in. So again, if set A is 4, -2, and 7, 3 is not an element of set A because 3 is not in there. It's not a member. N of A is the number of elements in set A. So we've got set A 4, -2, and 7. The number of elements in set A would be 3. All right. The C with a line under it is subset. So A is a subset of B is where every element in A is also in B. So for example, set A is still 4, -2, and 7. Set B is -2, 0, 1, 4, 5, and 7. Set A is a subset of set B. In other words, the 4 right here, -2 right here, and the 7, everything in A also shows up in set B. B is not a subset of A because not everything in B shows up in A. Okay? All right. C without the line under it is a proper subset. A proper subset B is where every element in A is also in B, but A does not equal B. So this example that we had up here, this is also a example of a proper subset where every element in A is also in B. So to help you figure out the difference between a subset and a proper subset, 4, -2, 7 is a proper subset of, A is a proper subset of B. And it's also a subset of B. But let's say if B was also 4, -2, 7, A would be a subset of B, meaning everything in A was in B, but A would not be a proper subset of B because B has to contain at least one thing that's not in A in order for it to be a proper subset. Okay, so that's the difference between subset and proper subset. Easy for me to say. Okay. The little 0 with a slash through it or the brackets with nothing in them is considered to be the empty set. And that's the set that contains no elements at all. Okay, so this would be the empty set. Would be the empty set as well. They have no elements in them at all. All right. Okay, let's take a look at an example, and then away we go. Okay, example 1. Let A equal -2, 1, tree, 7, and pretzel, and B is -2, tree, and 7. Find, for part A, find N of A and N of B. Okay, so N, again, if you remember, is the number of elements in. So number of elements in A, 1, 2, 3, 4, 5 things. So N, forgot about that. N of A is 5, not 3, 5. And then N of B, number of things in B, 1, 2, 3. Okay, total number of elements. True or false? 1 is an element of B. So here's B, -2, tree, and 7. 1 is not an element of B, so that would be false. Okay, we could say 1 is not an element, of B. That would be true. But anyway, they're just asking if it's true or false. Tree is not an element of B. Here's tree that's in B, so that is also false. If we wanted to fix that to be a correct statement, we would say that tree is an element of B. Okay? Is B a proper subset of A? Is everything in B also in A? -2, tree, and 7. All those are in there. Excuse me. And it includes A includes something that's not in B, so this would be true. Okay, is A a proper subset of A? So is everything in A also in A? Yes, but since they're the exact same set, there's in order for it to be a proper subset, this second one here has to include something that the first does not have, so that would be false. Okay, and then is A subset of A? Everything in A also in A? Yes, that would actually be true. Okay, because everything in A is also in A. The only reason why this proper subset is, again, the second one cannot have, second one has to have at least one other thing that A does not have, the first one. Okay, and then is A a subset of B? Is everything in A in B? That is false. But everything in B is in A. Again, they're not asking for that, but everything in B does show up in A. But not everything in A is in B. Okay? All right, that's all there is for the notes on sets. If you have any further questions, please feel free to ask in class. Thanks.